Welcome to Indefinite Integrals, Lesson 5, Integration by Substitution, where it's all about pattern recognition. Can you recognize that the derivative of x cubed plus 14, can you recognize that the derivative of that is 3x squared? Right here, right here. Can you recognize that? Hopefully you can, so you can use integration by substitution, where we'll change out the integrand to try to make it a little bit simpler. And here we go. It's all about u substitution. Alright, do you see the pattern? Right here and right here. So what we're going to do is we're going to let u equal x squared. Then the derivative of u is going to be, take the derivative of this with respect to x. 2x with respect to x. So wherever we see 2x dx, we're going to replace that with a du. So this is going to be the integral of e to the x squared, but x squared is u du. And we've completely changed the look of that integral, but we've made it a whole lot simpler. The derivative of e to the u is just simply e to the u plus some arbitrary constant. So our final answer, will substitute that u back in again. E to the x squared plus c. Sometimes there won't be an obvious thing to substitute, so we'll try to take care of the most complicated. The most complicated would be this 3x minus 7. So that's what we're going to use for u. U equals 3x minus 7. So the derivative with respect to u is 3 dx. Unfortunately, we don't have a 3 here. What do we have? We've got a 2x. So we need to simplify that. Divide both sides by 1/3. Sorry, multiply both sides by 1/3, or divide both sides by 3. So now we are going to substitute this dx with a 1/3 du. Put the 1/3 out front times the integral of 2x over u du. Uh-oh, hold on a minute. What's going on here? Alright, we have to let's go ahead and pull that 2 out front. 2/3 times the integral of x over u du. We can't have two different variables when we're trying to integrate. So what we're going to do is go back up here, and we're going to solve that u substitution for x. So u plus 7 equals 3x, and then we're going to divide both sides by 3. U plus 7 over 3 equals x. Alright, let's extend the page down. 2/3 times the integral of u plus 7 all over 3 all over u du. Pull out a 1/3. 2/9. The integral of u plus 7 over u du. Let's separate that up. 2/9 times the integral of 1 plus 7 over u du. There, finally we've got it in a form where we can take the derivative. 2/9 times u plus 7 ln of u plus an arbitrary constant. So 2/9 times, what did we say u was again? 3x minus 7. 3x minus 7 plus 7 times the ln of the absolute value of 3x minus 7 plus an arbitrary constant. Whew, that was a lot of work. Okay, we're going to let u equal, what are we going to let it equal? Okay, I see a secant times the tangent. Ooh, what's the antiderivative of secant times tangent? Secant. Yeah, okay. So if this were just a u, this would be a whole lot easier. So we'll say 5x plus 1. The derivative of u equals 5 times the derivative, well, with respect to x. But I only see a dx. I don't see a 5 multiplied out here anywhere. So divide both sides by 5. 1/5 du equals dx. I can replace this dx with a 1/5 du. 1/5 times the integral of secant u tangent u. Why did I write an n? Don't have a clue. Tangent u tu. So 1/5 secant u plus some arbitrary constant. Final answer all said and done. 1/5 times the secant of 5x plus 1 plus some arbitrary constant. Yeah, I know I'm making this look really easy. Alright, this one takes a lot of algebraic shenanigans and a little bit of trigonomic shenanigans. We're going to say that this is the integral of cosine of x times cosine squared x dx. That would be the integral of cosine x times 1 minus sine squared x dx. Just because of that trig identity, right? And now I think we're almost ready to do this. We'll let u equal sine x. What does du equal? Well, that would be the cosine of x dx. Ooh, look at that. There's our dx and cosine dx. So the integral of 1 minus u squared du. Wow, I don't understand that when that does that. Alright, so that would be u minus, add 1 to the exponent, 3 multiplied by the reciprocal plus some arbitrary constant. So that would be sine of x minus sine cubed x over 3 plus an arbitrary constant. Okay. What's the derivative of e to the 3x? E to the 3x. What's the derivative of ln of x? 1 over x. Okay, we're really close on this. No, actually it would be 3e to the 3x. Alright, so we're going to let u equal e to the 3x minus ln of x. Du would equal 3e to the 3x minus 1 over x dx. That's not quite what this is. So what we're going to do is we're going to divide both sides by 3. 1/3 du equals e to the 3x minus 1 over 3x dx. There we go. That's what we want, because that's what that is right there. So we have the integral of 1/3 times the integral of cosine of u du. So 1/3, antiderivative of cosine is sine u plus some arbitrary constant. Substitute back in. Sorry about that. There's my u. 1/3 times the sine of e to the 3x minus ln of x plus some arbitrary constant. Boy, I'm making this look a whole lot easier than it is, folks. And now let's go back. Almost what we had earlier. Pattern recognition. There's x cubed, there's 3x squared, the derivative of 3x squared of x cubed. So we're going to let u equal x cubed plus 14 du equals 3x squared dx. That doesn't work, because we have 1 over 3x squared dx. Oh boy, that doesn't help us at all. We're going to have to come up with some other way to do this, because we don't have a method for it right now. I doubt we're ever going to come up with a method for this one. So remember that when you're replacing and trying to simplify, that this thing right here will have to be in the numerator for this to work. You'll get better with practice. Yeah, I know. Crazy. This does conclude Indefinite Integrals Lesson 5, Integration by Substitution.